Alright, 3.5 continued. We're going to be looking at some triangle side lengths and the triangle inequality theorem. So if we look at this, it says which is the largest angle in triangle ABC? Well, by looking at it, we can recognize that it's obviously not B. This is the smallest. A, C, well, C looks bigger than A. And if you notice, well, C, this number is 9 compared to A is 8. Well, 9 is greater than 8, so this side is opposite this angle, so that angle is going to be the greatest. And if we say which side is the shortest, well, obviously we know that EF is the shortest side, and we compare it to this angle, that's also the shortest angle. So what do we think will happen in a triangle if the two angles have the same measures? Well, if these two angles have the same measures, well, what do you think about this side compared to this side? All right, the two opposite sides, the two sides opposite the angles are going to be the same. Two sides opposite the angles are congruent. So what we're looking at is, we notice that the largest angle here had the largest side, the smallest angle had the smallest side, and if the sides are the same, well, the angles are going to be the same. And if the angles are the same, the sides are also going to be the same. So we get to the two theorems we're going to need to know. If two sides of a triangle are unequal, then the measure of the angles opposite these sides are unequal, and the greater angle is opposite the greater side. If two angles of a triangle are unequal, then the measure of the sides opposite these angles are also unequal. The longer side is opposite the greater angle. So what are the largest and smallest angles? Well, we know that DF is the largest side, so the angle opposite is angle E. So the largest is angle E. The smallest, well, the smallest is going to be opposite side 4, which is angle F. So angle F is the smallest. So when we look at 2, well, 8 is the largest, so angle Q is the largest. The smallest is opposite side 3. Well, the angle opposite side 3, well, it's not P, it's not Q. That means it's angle R. So angle R is the smallest. And we have 5, 7, and 10. Well, 10 is the largest side, which is opposite C. So the largest is angle C. And the smallest, well, 5 is smaller than 7. Well, here's 5. 5 is opposite angle B. What are the longest and shortest sides? Well, we have 15, 130, and this angle is going to be 35. So the longest side opposite this, so DF. DF is the longest, and the shortest side is opposite angle D, so EF. The shortest is EF. So DF and EF. Number 5, we have 70, 35. And this one is going to be, that's 105, so 75 degrees. Now, which one is the largest? Angle R is the largest, so angle R is opposite PQ. So PQ is the largest side, the smallest side is opposite 35, so RQ equals the smallest. This last one, we have 100, we have 35, and then 45 degrees. 100 is the largest, so SV equals the largest. Shortest, 35, is opposite ST equals the shortest. And now we get to, if we have file tools, some straight lines. So we have a purple, a green, and a blue. Well, the first thing it says we have a purple, a green, and a blue. And if we connect them, can we make this into a triangle? Well, let me take my shapes. Alright, and now if we move these and we rotate them, can we make this into a triangle? Doesn't look like it. We're missing a huge chunk there. So, can we make this into a triangle? Well, the answer is no. Now, if we draw our picture, well, this is what my picture is going to look like. So I can, instead of drawing a picture, we just take a picture of it and say, well, no, we can't make it into a triangle. Well, if we take 3 purple and connect them, well, if I take my 3 purple and we copy it, copy, now we can paste it. There's 2 purples and 3 purples. Now, can we arrange these to form a triangle? I should have used bigger lines. Would have been easier. There's 1. And we can turn this. I'm just going to take a little bit maneuvering here. But yes, we can make these form into a triangle here. Almost there, so we just have to bring these 2 down a little bit. So, we can form this into a triangle. So here's my picture. And then the last one, if we take an orange, a green, and a red, and can we connect them? Well, now we need an orange, a green, and a red. So let me make my modifiers, give me my straight lines. We'll make these a little bit bigger so they're easy to work with. We have a red, an orange, and a green. Now let me see if we can move these so that we form a triangle. So we can turn. Don't want to do that. Undo it. And now we can move it. And we can turn this one. And move this one. And there we have our triangle. We can make it a little bit better. So we have a triangle. So no pictures, so we have our 3 things. So one we were not able to, one we were able to, and the second one we were also able to. But what we need to know about this is the triangle inequality theorem states that any side of a triangle is always shorter than the sum of the other 2 sides. So the first one we had 2 smaller ones and a big one. This one we had just, they were all relatively the same, and in the third one they were all the same size. So the sum, the sides of a triangle is always shorter than the sum of the other 2 also. A triangle cannot be constructed.
7th graders should report to lunch, and 8th graders should report to this period. Once again, students, at the sound of the bell, 6 and 8.
Alright, a triangle cannot be constructed from 3 line segments if any of them is longer than the sum of the other 2. So our big idea for any triangle, for any 3 sides you choose, when you add one side to another, your answer has to be more than the third side. So when we're given these points, we added 2 smaller ones together, has to be bigger than the third one. Well, 5 plus 4, that's 9. 9 is greater than 7. So this is 9 is bigger than 7, so this is yes. We add the 2 smaller ones. Well, 3 is less than 8. This is no. Or here's number 2. We add the 2 smaller sides. 3 plus 2 is 5. 5 is smaller than 6, so this is no. We add the 2 smaller ones. That's 6. 6 is greater than 5, so this is yes. The two smaller sides, so we have 9 is less than 11, so that's yes. The two smaller ones, so 9 is greater than 8, so that's yes. The two smaller sides, 4 and 7, 11 is greater than 8, so that's yes. The two smaller sides are 11 and 9, so 20 is not greater than 22, so that's a no. Once again, 3 and 8, 3 plus 8 is 11, that's greater than 10. So you get the idea here. We're taking the two smaller sides. Well, they're the same. Well, 13 and 13. Well, 13 plus 1 is 14. Well, 14 is greater than 13, so that's a yes. And we look at the next one, and we can continue with this. Two and 15. Well, 2 plus 15 is 17 is greater than 16, so that's a yes. And then we have 8 and 10. That's 18. Well, 18 is not greater than 18, so this is a no. And then the last part here, we have a range of values. We find a difference of the two sides. One's positive. We add them and we subtract them. So what we do is 9 minus 5 is 4, and 9 plus 5 is 14. So x is any number in between 4 and 14. We subtract them. 8 minus 5 is 3. 8 plus 5 is 13. So it's any number between 3 and 13. 6 and 10. 10 minus 6 is 4. 10 plus 6 is 16. So x is any number between 4 and 16. And we can keep doing this. We subtract them and then we add them. So x is any number between 3 and 15. And then answer the last two and we'll go over it tomorrow.